Welcome to RailsConf 2020 Couch Edition and Enterprise Identity Management on Rails. I'm Brynn Gitt.
And I'm Oliver Sanford. We're software engineers at Mode Analytics.
This talk is not about resetting passwords. We don't like passwords very much, and we're assuming you're already familiar enough with Rails to have seen what password management typically looks like. We're also going to skip right past session storage. Yes, in a web app, session storage is the backbone of identity management. It's something you have to handle in a way that suits your scale and infrastructure. The various Rails session stores are well covered elsewhere. This talk is also not about Real ID verification, biometrics, or other new forms of strong identity verification for government or health processes. It is about several topics you'll want to consider if you're building a product or service for larger businesses. This talk is about some of the lessons we've learned in handling identity concerns in Rails apps, and particularly through debugging SAML and developing a Skim integration. We'll start with a big picture design consideration, and then we'll look at a couple areas more closely, handling enterprise authentication in Rails and implementing Skim.
The obvious, but wrong way to set up an identity management in Rails is to have all users share a single space. Users belong to an organization. Validate that no two user accounts can have the same email or username, and you're done, right? Wrong. Actually, sometimes the same person belongs to more than one organization. Add a memberships table, and voila! Users can be part of more than one organization. Here's where the trouble starts. You'll run into policy conflicts immediately. When two organizations have different login policies, which one do you apply? If someone has logged in successfully according to one organization, using a strategy or provider that another organization otherwise wouldn't, what is their authorization level? When a person is removed, which organization has permission to delete their account? A better approach is to scope users to organizations from the beginning of your project. With this approach, you'll validate traits like the email and username only within a single organization. If billy@greenfield.com needs to be part of two orgs, each org will need to maintain a separate billy@greenfield.com account. To understand the consequences of the two different design patterns, let's compare GitHub with Slack. GitHub emerged out of an open source-oriented ethos. Much like Twitter, developers had handles in a single global namespace of users. Slack was designed for the enterprise from the beginning. You log into a workspace specific to your organization. The GitHub model is oriented toward global interactions and sharing. A user can certainly still belong to an organization. However, things become more challenging when they belong to multiple organizations. I definitely logged into my personal GitHub account recently to discover I was still a member of a large organization I stopped contracting for 3 years ago. The fact GitHub has developed its Enterprise Cloud Edition, which offers unique username account spaces, SAML authentication, and Skim integration at considerable additional cost, speaks to the effort required in rebuilding or refactoring their service to move away from the global namespace pattern. To the extent that GitHub is really a B2B service, that is, if the platform is mostly used while people are at work, with their employers paying for it, the open source model becomes extraneous. If you have the luxury of planning for enterprise support from the ground up, take those early decisions carefully. How can you design your product or service so that enterprise identity management is a breeze? Probably the best gift you can give yourself is, if you are building a business product, scope each user account entirely to a single organization. If you need individuals to have accounts, either add them all to an invisible general public organization or make them each an organization of one. Observability is fundamental. Identify and define any regular business events you want to log, such as authentication success or failure, a user provisioned event, or a user deletion event. In an existing service, your product probably already has service objects to handle exceptions and analytics. Use them. If you don't have them yet, build them. Half the battle in development is exploring and tuning a living system. If you work with a running system locally and explore actual payloads, you'll find it makes the documentation much more concrete than the formalistic description of an RFP. Even for local development, a log visualization product will serve you well compared to manually parsing the Rails logs for everything you need to find.
Omniauth. Many Rails apps start out life offering authentication via username and password, perhaps using something like Devise. Try to skip this step. Storing individual passwords is insecure and risky. Avoid it if you can. What's good about Devise is that its modules implement many fundamentals of identity management in an itemized way. They're instructive and represent concerns you may still want to address, even if in a way that fits better with your existing practices. For our purposes, the minimum viable implementation is single sign-on via some combination of public OAuth 2 vendors. Users will click on the first available single sign-on button and defer to an external service. At this stage, you'll need something more modular than username and password implementation. In the Rails ecosystem, that something is Omniauth. Omniauth really has only one central idea. All forms of authentication boil down to a request phase and a callback phase. In the request phase, we check for evidence of the user's identity. We look for an existing session and ask for credentials if we don't find it. In the callback phase, we pass verified identity information to your application and handle anything required to log the user in. Omniauth supports some useful hooks, such as before request phase, a good place for CSRF verification and sending information to analytics, before callback phase, and on failure. In between, it delegates the actual work to whichever authentication strategy is appropriate. Depending on your customers, you may find Google OAuth 2 is the most popular single sign-on method, or perhaps GitHub or Azure Active Directory. In these cases, you're connecting to public OAuth 2 authorization servers, and the connection details are more or less the same for all your customers. So you'll wind up with something that looks like a pile of configuration constants for various Omniauth authentication strategy gems. This may work for a while, but there are some disadvantages to this system. Not all your customers will have all the login methods set up, so people will likely click on the wrong thing and wind up in a dead end. Moreover, your customers may require you to ensure their team only log in with an approved strategy. Gate access to both the request and callback actions where possible. Since your system now supports multiple authentication providers, you'll need to track the appropriate external UID for each of them. You'll find it in Omniauth's auth hash and save it to an identity model associated with the user. At this point, the minimal possible ERD looks something like this.
SAML stands for Security Assertion Markup Language. The 2.0 specification was approved way back in 2005, before the world saw its first iPhone. SAML has some limitations, but it's fully realized and fairly widely adopted in larger organizations. It's a dialect of XML, with a few interrelated documents you may wish to handle. With the public OAuth 2 vendors we discussed in the last section, most of your connection details were constants. No worries. It won't be long before customers want to connect to identity providers entirely under their own control. They might ask you to do this with OAuth 2, but we've found the most widely requested enterprise authentication protocol is SAML. In the future, it may be OpenID Connect. A SAML authentication flow can be initiated either directly from the identity provider, or it can be initiated from the service provider. That's your service. There are some good reasons you want to initiate the request yourself. Your request will likely have a short timeout associated with it, and may also contain some disposable, immutable data you wish the identity provider to send back as part of the SAML assertion. In the OAuth 2 world, the SAML assertion would be called an authorization token. Both measures help mitigate the risk of man-in-the-middle attacks. In a SAML authentication flow, the security assertion, or SAML response document, contains the verified identifying information of the logged-in user. So once the SAML response is received by the client and submitted to the service provider, the authentication flow is done. The service provider may decide not to log the user in for some reason, a policy violation regarding a particular resource, for example. But from the moment the client sends the token, the response document, back to the service provider, the identifying information has been delivered. Of course, it's also essential it be signed, so SAML documents should always contain a signature that matches the rest of the information provided. The main issue with SAML became clear within a few years after the release of 2.0. It's that request assertion consumer service step, which the client provides the security assertion to your service provider. The SAML specification makes the assumption that the client is a web browser and supports transport for this final step using either post or redirect. This diagram implicitly shows the post variant, since it responds with an XHTML form. But for mobile clients, this step does not work. OAuth 2 addresses this limitation, providing for direct communication between the service and the authorization server. The catch is that the identifying information is not provided to the user as part of the authentication token. Rather, the service provider has to request it as part of the verification step. If you need to support multiple customers with their own identity providers, take a look at Omniauth multi-provider. This makes it easy to pull the parameters for a SAML strategy out of an active record model. One limitation of Omniauth is that while SAML 2.0 supports automatic configuration through metadata exchange, and Omniauth supports an options phase for uses like that, Omniauth multi-provider will need some extra tuning to get that to work. In the meantime, consider setting up a feature flag or environment toggle you can use to log the full XML of SAML assertions. In the event a particular customer has trouble setting up their SAML provider, you can grab the assertion and see exactly what is required.
Debugging in practice. Here are a few other suggestions that are useful for debugging SAML and other authentication protocols. Set up test organizations with your most popular identity vendors, such as Okta or OneLogin. Even if it's an identity provider that your organization also uses internally, you probably won't be able to use your organizational account to do development and debugging. Instead, you'll want a test organization. With the larger vendors, such as Okta, this is not necessarily included in your contract, and it's something you'll want to negotiate. If you use trial accounts for development and testing, you'll find that they may expire and lose valuable state every 30 days. To avoid this, you'll want your vendor account manager to include permanent testing resources from the beginning. Rather than rely on a SaaS vendor with a large surface area, another option that's helpful for understanding SAML is to debug against an open source identity provider, such as Keycloak. This has the advantage of being free. Plus, you can quickly set up and run the identity provider locally using Docker. Keycloak is certainly a thinner solution than Okta, but in practice, this makes it easier to locate the certificates and settings you need, and to see how settings on the identity provider side match up with things you're seeing in Ruby. You'll also want to be able to inspect authentication flows in process from the client perspective. For this, use ngrok or a SAML browser plugin. The latter adds XML decoding and inspection to your browser developer tools. It's super helpful to be able to see exactly what's being sent for each stage of the flow and to decode the SAML assertions right there.
Before you get your Skim implementation in place, you may need to handle account provisioning just in time after your single sign-on auth response is received. The main idea is to treat the authorization token as being authoritative. That is, if Google says that Billy Moore from Greenfield is at your door, and you don't have an account for Billy Moore yet, you can create one for him as part of the login flow. This is what we call just-in-time provisioning. As we'll see shortly with Skim, a SAML plus just-in-time provisioning scenario raises a couple of edge cases which you'll need to think through. Among them, email and name changes, as when an individual gets married, and email inheritance, as when Billy Moore departs and Billy Strayhorn arrives, and also wants to be billy@greenfield.com.
What is SCIM? SCIM stands for System for Cross-Domain Identity Management. Note that throughout this presentation, when we say SCIM, we are referring to version 2.0 of the Skim API. It is an API that is implemented by a service provider and used by an identity provider to manage resources on the service provider. As a B2B company, we implemented the Skim API to allow our customers to manage their users and groups through third-party software, specifically starting with Okta. This gives the administrators at our customer organizations more control over who can access our product and the permissions they have within our product. There are two portions of the Skim API, discoverability and operations. The discoverability portion of the API tells a client about the supported features, resources, and attributes that the operations portion implements. The operation portion of the Skim API provides the abilities to create, read, update, and delete resources, search for resources, and perform bulk operations on those resources. The two resources defined in the Skim API are users and groups. However, this can also be extended to other resources in your application. Here is an example of the user resource. We can see many of the attributes that are defined in the Skim core schema. And here is the group resource. There's a lot to take in here from these two resources. So to start off, we will want to determine how much of the Skim API we need and want to support in order for our administrators at our customers to manage resources in our application in an efficient way. This will narrow the scope of our Skim API. We will want to think about how Skim interacts with our internal permission structure. If we use groups to assign permissions, we'll want to implement the groups operations of the Skim API. We could also use a roles attribute on users to specify multiple values, or the user type field to specify a singular value. For our application, we use both roles and groups for different permissions. So we will implement the roles attribute in our Skim API and support the groups resource. We have also worked with our product managers, customer success, and sales teams to determine which identity providers are the most valuable to our customers. We have decided to start by integrating with Okta, so we will only need to implement the portions of the Skim API which Okta requires. It's important to also spend time researching the other identity providers we may want to support in the future. We don't want to dig ourselves into a hole by ignoring the rest of the Skim API and missing a crucial piece from the beginning. So we will remove some of the user attributes from the user resource that we don't need to support and add some others to get our supported user resource. And we'll do the same for groups. Our resources are starting to look more manageable now. We will also be able to limit which endpoints are included in our first iteration of our Skim API by only implementing those that Okta uses. This eliminates the entire discoverability section of the Skim API and the bulk operations too. So isn't there a gem for all this? Let's take a look at 3 gems to help us implement the Skim API. Skim Kit by Mo Khan, Skim Rails by Lessonly, and Skim Engine by Cisco AMP. Each of these gems covers a slightly different piece of the Skim API. Skim Kit covers the discoverability portion, while Skim Rails covers the operations portion, but only for users. Skim Engine covers both the discoverability and operations. The Skim Kit gem focuses on the schema and resources your application supports. It helps provide the discoverability portion of the Skim API, telling an identity provider about how to use your API. It doesn't help you implement the operations portion of Skim. So after implementing this gem into your Rails application, you will still need to do all the work to manage resources. The pieces of the Skim API that Skim Kit will help you implement aren't required by Okta. So for us, this meant skipping this entirely in order to narrow our scope. Next up, we have the Skim Rails gem. This gem is not fully Skim compliant. It focuses on the components of Skim that are required by Okta. Within the set of features Okta supports, this gem helps implement the Skim API for users. It doesn't support groups or adding other resources. This gem also makes assumptions about how your underlying data models look. It assumes your users are organized within a company that has a scope to get the users. It assumes that your data model matches the core Skim schema. Due to our existing code, there wasn't enough flexibility here to add support for groups and handle the differences between our data models and the Skim core schema. Lastly, we have the Skim Engine gem. This gem aims to be more general purpose than the Skim Kit and Skim Rails gems. It supports the core schema endpoints, the operations endpoints, and can be extended to have multiple resource types. There are still pieces you will need to implement yourself, though. To be fully Skim compliant, you'll need to implement the index action with filtering, handling patch parameters, and other application-specific logic. That other logic is summarized nicely in an example controller in the Skim Engine repository. Convert the Skim Engine resources user to your application object and save. This is definitely easier said than done. Factoring your Skim API endpoints is the hardest part of writing your Skim API. It constantly poses the question, should I really do what this request is asking? The answer to this question lies in the permissions of your application. In our case, users belong to organizations, and organizations have domains. If a request comes in for a user with an email address domain that belongs to the organization that's making the request, we do it. We use domains as an additional way to determine if the request has permission to create or link to users with a specific email. In addition to linking users, we also ran into some edge cases and questions from our customers. These edge cases also apply to SSO with just-in-time provisioning. The first edge case we ran into involved emails. Someone got married or decided that Goat Lover was not an acceptably professional email handle. With Skim, it's now time for your administrator to link your accounts. They use your first name, last name email in the identity provider, and it doesn't link to your Goat Lover email handle that you used to sign up for the service provider with. Instead, you have a fresh blank account that is missing all your previous work. In this case, we provided our customers with instructions on how to remove the new account, change the email within our application on the old account, and then to retry the Skim request. Another solution would be to use the Goat Lover email handle in the identity provider and then change it within the identity provider to trigger an update operation on our Skim API. In this case, we are expecting the request to have an external UID that matches an existing user and a new email address or other changed attributes. For the future, we've also added this scenario as a warning in our Skim integration guide. SSO with just-in-time provisioning handles this similarly. When we get the SSO login request, we can check both the external UID and email address. If the user already exists in our system, as determined by their external UID, but the authorization token specifies a different name or email address, we're looking at an email change. On the other hand, we may see that the external UID has changed, but the email does already exist in the system. And so we have a slightly more subtle situation to think about. This happens when Billy Moore departs and Billy Strayhorn arrives and really wants to be Billy at mycompany.com. It really depends on how the external system treats email addresses. If it does not enforce email uniqueness, stop right here. There's nothing really you can conclude, and your customer will have to take certain administrative actions manually. If you can assume that the email, though it might be mutable, is unique within the customer organization at that moment, then when your auth handling code sees the new external UID coupled with an old email address, it probably means the old UID is now inactive or defunct. Someone has left the customer organization and you are now looking at a new person. This is email inheritance. Checking the external UID is the solution for both SCIM and SSO with just-in-time provisioning. The challenge here is that the correct provisioning action is then to deactivate or delete the prior user account. However, in a mature system, these actions may not be so easy to take. A user may have many associated records that are shared and accessed within the team. You will have to be careful about what you delete and how you manage the disposition of any ambiguous situations. For instance, if the user who's scheduled for deletion is the creator or owner of a resource, to whom does that resource fall in the person's absence? It's also possible user or administrative error has led to this situation, in which case you better hope there's an easy way to undelete anything you may need to delete in order to provision the new account for the email inheritor. When you decide to deprovision a user in the course of another user's login or SCIM request, that's a significant business decision. You will definitely want to make sure that you have observability and maybe even proactive alerting for these events. Next, we'll talk about testing your Skim API to ensure it will work with identity providers to manage resources on your application. There are a couple of things we want to confirm when testing our Skim integration. The API complies with the format specified by the Skim protocol. Each endpoint implements the business logic we expect to take place. Requests are authorized appropriately and only modify resources they should have access to. Integrating with our preferred identity provider works. We're able to make changes in the identity provider and see those changes within our application. This also includes running through common and uncommon administrative workflows. So for each of these, there will be different tools you can use. Okta provides tests for your API and basic tests of integrating with their preview environment that work with BlazeMeter RunScope. You'll also want to include RSpec or another framework for integration and unit tests, and possibly penetration testing to ensure that only authorized users are accessing and making changes through your Skim API. Okta also requires an entire suite of manual testing to be done through the Okta preview environment. This manual testing is tedious, but it will teach you how to use Okta as an administrator and show the workflows administrators use for common tasks, like assigning users to your application, deactivating and suspending users, and pushing groups. If you don't know how a specific workflow is done in Okta, you can probably find it in the manual testing spreadsheet. We also relied on a tool called ngrok to capture and replay requests that hit our Skim development server. When your Skim API is working, you can then submit it to Okta Integration Network. In order to submit, you'll need to provide Okta with an integration guide, show passing automated tests in BlazeMeter RunScope, confirm the manual QA test pass, and provide testing credentials for your application. Each time we contacted Okta, there was about a 1-week turnaround. Our initial feedback involved updating support contacts at our company, removing optional BlazeMeter RunScope tests that were not passing, providing testing credentials, and confirming that we did the manual testing of our integration. Our first two bugs came from a race condition on creating users quickly and business logic for our application that needed to handle periods in email addresses. The next round of bugs involved asking us to update screenshots in our integration guide and an error on the Okta test stand about how to use the roles attribute for our application. There was a typo in the role they assigned. After one more round of updating screenshots again in our integration guide, our application was approved. It took about 5 weeks from first submission to getting final approval.
We hope you have enjoyed hearing the lessons we've learned in handling identity concerns in Rails apps, debugging SAML, and developing a Skim integration, and have taken away some design considerations and insights into enterprise identity management on Rails. Thanks for watching.